Part 3. 2 tools to help you choose a camera and lens. These tools are meant for DSLR or mirrorless cameras with swappable lenses, but they will work for other cameras such as a webcam or a Raspberry Pi HD camera. But realize that the quality of lenses from companies such as Canon, Sony, and Nikon will likely far exceed lenses for a Raspberry Pi or web camera, and with lower quality lenses you have to worry that there may be some distortion which could shift the fringes slightly. If you shift a fringe by 1/10 its width in position, then that potentially adds 1/10 wave error depending on the characteristics of the lens distortion. So all the cameras I have in these tools can be divided into full frame or cropped frame, sometimes called APS-C sensors. Full frame sensors are the same height as the old 35mm cameras, which is 24mm tall and 36mm wide. We only care about the height as interferograms are round, and cropped sensors tend to have a crop factor of about 1.5 or 1.6, which means they tend to be about 16mm tall. For most cases, I recommend the cropped sensor cameras as they cost about 1/3 to half as much and will usually work well with 50mm focal length lenses, which also cost much less than the 85mm lenses you may need to switch to if you use a full frame camera. But let's get into the tools, which are web pages. This one I call Camera Chart, and this is how it starts out when you first come to this page. Initially, only the Nikon D3100 is checked with a 50mm lens, as that covers most mirrors and is quite cheap at about $200 or euros for the body and about $50 or euros for the lens. These are used prices on eBay. I've bought used cameras and lenses used on eBay, and they are usually excellent. Mirrors that can be tested with this camera and lens are inside the blue shape. The gray circles are typical amateur mirrors. We have F number on the vertical axis and diameter on the horizontal. It defaults to inches, but you can switch to centimeters here. You can zoom in by clicking and dragging, or zoom back out with this button, or you can click this other zoom out button to see the whole plot. When you get to more difficult mirrors like a 29-inch f3.3 or a 32-inch f3, you need to change your camera or lens. Let's say you want to test a 20-inch f3 mirror. Well, you can enter that down here and hit Set, and that will show you a green dot for your mirror. It's right on the blue line. There is a little margin, so you would be fine with the D3100, and you could switch to see the other tool to see what the issue is. But let's try the D3200, which has more pixels. You can see over on the right that the D3200 is the red line, and now our mirror is well within that ability. The left side of these outlines is the minimum focal distance for the lens. I used a specific lens, so other 50mm lenses may have a different minimum focal distance. This comes into play with unusual mirrors, such as a 1-inch f4 mirror. Most cameras won't be able to focus on that at all. You will probably want a macro lens. The top of these graphs is probably not an issue, but with higher f-number mirrors, you are going to have a smaller and smaller igram in your camera. I chose a minimum of 600 pixels for the igram, but you can go down to 400 pixels no problem and still get good analysis, so the tops of this graph could be much higher. The bottom flat area of these graphs is related to having the igram so big that it doesn't fit in the vertical field of view. If you are hitting this limitation, you might want to switch to a full frame camera or a shorter focal length lens. But not many mirrors are faster than an f1.8. The right curve in the graph is set by the width of the fringes. With larger and faster mirrors, you will need more tilt, which means smaller fringes. I set the limit to 6 pixels per fringe, but you can go down to 4 pixels per fringe. But if you are on the edge of this limit, you will have to mess around with tilt a lot to get the perfect tilt that doesn't exceed 4 pixels per fringe. To move this curve down and to the right, you need either a camera with more pixels or longer focal length lenses. If I put an 85mm lens on the D3200, we can now test this 32-inch f3 mirror, the green outline. If we go to the Z7, a full-frame 45 megapixel mirrorless camera with an 85mm lens, the black line, you have even more margin. I only show 3 Nikon cameras, but you can enter your own data for any other cameras and lenses down here. The reason I am partial to Nikon is because when I search for used Nikon and Canon cameras, the prices for the equivalent Nikon cameras are all lower, and the quality and functionality of these cameras is just as good and usually have more megapixels. Let's switch over to the other tool. There is a direct link here, Camera Chooser. This is an easier tool if you already have one or more cameras. So first enter your mirror information. Let's say it's a 12-inch f4. Very easy to test. We can see the null is minus 2.4 waves. 2.4 is easy. Greater than 10 gets quite difficult. Conic constant is -1 for parabolic. Now notice the blue text here wants you to choose a camera. So let's click that, and you can see lots of camera options here, including some Raspberry Pi stuff, but most of the strength of this utility is with Canon and Nikon cameras. Let's assume you have a Canon, so choose that and choose your camera. The green ones are recommended as they are cheap and have all the needed features for most mirrors. The red ones will not work because they don't have live view. Let's say you have the EOS 5D. You can see that it's not going to work. Let's say you also have a 60D. All that this does is fill in the sensor size and number of pixels vertically on the sensor. 3456 pixels. Obviously, you can just enter any information you want for any kind of camera, from a cell phone camera, a web camera, any kind of camera. Now we go down to the Choose a Lens step. It's telling us we need a lens from 10.1 to 119 millimeters focal length. That's a lot of lenses to choose from. Then I also state that a 50 millimeter lens will work, and it's the cheapest option. It's the best option, really, right in the middle of that range. It's recommended to get f2 or faster for the virtual pinhole issue. If you hover over the eye, you get information on virtual pinhole stops, and it will link to my video about that. More on this in a moment. Let's click Close, and we see 50 millimeters and f2 is already filled in. Scroll down and we see what the igram will look like in relation to the field of view, or FOV. This igram has a little bit of defocus to get slightly fatter fringes, and it has a reasonable amount of tilt that gives you no bullseye patterns. There's a zoom view which is helpful for more extreme mirrors like a 30-inch f3. Now notice above the igrams there are 5 lines of text, and none of it is yellow or red. Yellow or red indicates a problem. We see the pixel per fringe is 19.8, which is greater than the minimum, which is 4. By the way, the minimum should be 2, but color cameras have a Bayer filter, which cuts the resolution of red igrams by 2x horizontally and vertically. Let's simulate problems. We were told the focal length had to be between 10.1 and 119, so let's mess with that. We put in 10 millimeters for the lens focal length, and we see a red 4.0 for pixels per fringe. Ignore the blue circle for the moment. Now let's try 120 millimeters. Well, now the igram is just barely cropped at the top and bottom of the image. If we put in 110 millimeters, there is no cropping, but there is yellow text because trying to align the camera to keep the igram in the center will be a pain in the neck, even with a tripod. You may have to adjust the camera 20 or 30 times before you get it just right, depending on how solid your tripod controls are. Finally, let's go back to 50 millimeter lens, but try an f11 lens. Now that blue circle is at the outer edge of the igram, and we see yellow text. This is the virtual pinhole stop situation that I discuss in my Part 2 video. I calculated the blue circle based on typical lens construction, but different lens manufacturers use different designs, so it might work, but probably not. If you go to f16, it will go red. The blue circle is an estimate. Let's say you don't have a camera and need to buy one. So let's go back and get a recommendation. It's saying any of these will work. It's not always correct, but let's hit close and you can see it's only recommending Nikons with a small sensor. That's because of price. Why pay much more for a camera that isn't needed when these are very high quality cameras? The green ones are recommended. I usually show the same thing here no matter what, but not always. Now let's try a 30-inch f3. Now the Nikon 3200 is higher resolution and the software knows the 3100 isn't the best choice. But the software isn't smart enough to be sure it will work, as the code for choosing lenses is more sophisticated. So it chooses the 3200. We next click the Choose a Lens and it gives us a range of focal lengths from 37.2 to 92 millimeters. So a 50 millimeter lens will work here. An 85 millimeter might be better. Let's hit close and see what we have. The biggest issue is that the igram is only 5.3 pixels per fringe. A higher resolution camera might be really nice here, or a little bit longer focal length. The 85mm lens is about $200 used on eBay. Let's enter that. Now we are up against the igram almost filling the view, but it won't fill the view. So this is probably the better option, as we now have 9 pixels per fringe. So either lens will work. Alternatively, let's search for a camera with more megapixels. You can see here the D3200 has exactly 4,000 pixels. Let's find more choices. Let's set that to 4001 and hit search. Let's stick to small sensor cameras, as if we go for a full frame, we will definitely need that 85mm or longer lens. Going small sensor and more than 4,000 pixels knocks out all the Nikon cameras. So there is the Canon EOS 90D with 4,640 pixels and gives us 6.4 pixels per fringe. You could then check prices for all these cameras. Or you could go full frame with at least 5K pixels, and we see the Z7 among other choices. Nikon sells a 105mm f2.8 lens that should work nicely. This would be a great choice of equipment, but you may have to pay $1,500 or euros for this equipment used. It's possible that the 105mm lens will crop quite a bit, but unlikely. But if it did, you could certainly use an 85mm. Notice that there is a link back to the other tool right here at the bottom of the page. So those are the tools. I hope you find them useful.